Hello everyone. In this video I am going to explain inductive effect, one of the electron displacement effect. To explain electron displacement in covalent bond, organic molecules contain covalent bonds. To explain electron displacement effects in organic molecule, there are 4 electron displacements which explain how electron, bond pair electron, covalent bond, pi bond shift, electron pair shift in the molecule. So there are 4 effects. There are 4 effects which explain electron displacement in organic molecule. Electron displacement in organic molecules. So what are those 4 effects? One is inductive effect. Second one is mesomeric effect. Third one is hyperconjugation. Fourth one is electromeric effect. So in that, first one is inductive effect. Inductive effect is the first electron displacement effect. Inductive effect, shortly I effect. Inductive effect, shortly I effect. What is inductive effect or I effect? Polarity produced in non-polar bond. These are non-polar bonds. Taking one more carbon. Why these are non-polar bonds? Because both are carbon atom similar electronegative. These two are carbon atom similar electronegative. Whenever a bond is formed between similar electronegative atom, those bonds are non-polar bonds. These bonds are what? Non-polar bonds. In these bonds, polarity induced due to presence of some different atom, whatever may be the atom. Here this is the Z, some Z atom. Z atom is different from carbon, that's why that may attract bond pair electron towards itself like this, or that may push electron towards carbon chain. Other type of possibility is also there. The Z may push electron towards carbon chain. So this is definitely polar bond. This is polar bond. Why is it polar? Your carbon, due to shift of electron towards Z become partial negative and carbon become partial positive. Partial positive negative charges developed. Polarity produced in this bond, polar bond. So partial displacement of bond pair electron. Here electron shift towards carbon, then carbon become partial negative and Z become partial positive. That's why this is also definitely what? Polar bond. This is polar bond. Now what is inductive effect? This polar bond induction, this polar bond induce this polar bond induce polarity in non-polar bonds. This polar bond induce polarity in non-polar bond. Okay, so since it is partial positive, it attract bond pair electron towards itself like this. Then it become some partial positive, partial positive. Then this bond shift towards this carbon, then this become partial positive, very less positive. And this bond shift towards this partial positive carbon, this become partial positive. That means this is very less positive, some more positive, highly positive, okay, negative. The polarity induced in non-polar bond due to presence of polar bond. Here, since it is the negative, electron push towards this carbon, then this become partial negative, and electron push towards this carbon, this become partial negative. Electron shift towards this one, this become partial negative. Thus, actually bond between carbon atom, non-polar bonds. In non-polar bonds, polarity is induced. This is called as inductive effect, induction of polar bond on non-polar bonds. Induction of polar bond on non-polar bonds. Induction of polar bond on non-polar bonds. This is inductive effect. Hope you understood. Polar bond induction on non-polar bonds. This is called inductive effect. So I am writing definition. What is inductive effect? So in this case, two types of inductive effect. I will write later two types of inductive effect. First of all, I want to write what is inductive effect. Very important concept. Very core topic of organic chemistry. Important topic. So, what is inductive effect? Polarity induced in non-polar bond. Polarity induced in non-polar bond due to presence of adjacent polar bond. Due to adjacent polar bond is known as inductive effect. Polarity induced in non-polar bond due to presence of adjacent polar bond. Polarity induced in non-polar bond along the carbon chain due to presence of adjacent polar bond is said to be inductive effect. Polarity induced in non-polar bond along the carbon chain due to presence of adjacent, that's perfect definition, that will become perfect definition. So what is the inductive effect? Polarity induced in non-polar bond along the carbon chain, in molecule due to presence of adjacent polar bond. Due to presence of adjacent polar bond. Due to presence of adjacent polar bond. in organic molecule is known as inductive effect. It is important to understand the definition first. Inductive effect. What is inductive effect? Polarity induced in non-polar bond along the carbon chain. We have seen just now. Polarity induced in non-polar bond along the carbon chain due to presence of adjacent polar bond in organic molecule is known as inductive effect. Okay, so inductive effect is two types. Inductive effect which occurs along the carbon chain due to inductive effect polarity produced in non-polar covalent bond. See here, same I am writing, this is what some Y. Okay, I will write this is some Y. This is some Z. Okay, here if it is polar bond, Y attract bond pair electron towards itself. Then Y become partial negative and carbon become partial positive. Then this bond pair shift towards first carbon, but not this much shift. This is almost near to Y here, this is just near to carbon. That's why this carbon become partial positive. Partial in partial, it become little. Then this bond also shift towards this carbon, then this become very partial positive, less positive. Then this bond also shift towards this carbon become partial, very partial positive. After 4 carbon atom, inductive effect is negligible. Along the carbon chain, after 4 carbon atom, inductive effect is negligible. Take this is different. If Z push electron towards carbon chain, then Z become partial positive. Due to shift of electron towards this carbon become partial negative. Then that carbon push electron towards this carbon, second carbon. Then second carbon become partial in partial negative. Then second carbon push electron towards third carbon. Then this carbon become partial, very partial negative. Then that electron push electron towards this carbon. Then this become very partial, very less negative. Some more negative. After 4 carbon atom, inductive effect is negligible. After 4 carbon atoms, along the carbon chain, inductive effect is negligible. After 4 carbon atoms, inductive effect is negligible. Here in this case, this is called when the electrons are moved towards the substituent away from the carbon chain. towards substituent away from the carbon chain, that is called as minus I effect. That is called minus I effect. If electrons move away from the substituent towards the carbon chain, your carbon chain getting electron positive, your carbon chain losing electron negative. So this is what positive inductive effect. Positive inductive effect. This is negative inductive effect. The group which causes positive inductive effect is said to be minus I group. Here Y is what? Y is what? Y is minus I group. Here Z is what? It causes plus I effect. So it is called plus I group. Positive inductive group, negative inductive groups. So inductive effect, the inductive effect is two types. So just I want to write second point. Next point. Due to inductive effect, partial shift of bond pair electron along the carbon chain takes place, not complete shift. If this Y takes electron, it becomes complete negative. But I am not talking about complete taking of Z. Just bond pair shift towards Z. Just shift towards Z, but not Z taking away electron. Okay, just partial shift. So in inductive effect, there is a partial shift. There is a partial shift of sigma bond electron, sigma bond pair electrons along the carbon chain, along the carbon chain, is observed. Okay, only partial shift of electron towards carbon chain, not complete shift. Next point, inductive effect is two types. Inductive effect is two types. What are they? We have just seen, that is what? Negative inductive effect and positive inductive effect. Negative inductive effect and positive inductive effect. What is negative inductive effect? In that first one, just I want to write inductive effect, positive inductive effect, or otherwise negative inductive. What is negative inductive effect? Very, very important concept. Negative inductive effect. Inductive effect, mesomeric effect, important. What is the negative inductive effect? Whenever this is the negative inductive effect, whenever sigma bond pair electron, sigma bond pair electrons move towards substituent or shift towards substituent, when sigma bond pair electron, all these are sigma bond pair electron, shift towards substituent along the carbon chain. This phenomena observed along the carbon chain. When sigma bond pair electron shift towards substituent along the carbon chain, it is referred to as what? minus I effect. It is referred to as what? Minus I effect. Okay. So what are examples of minus I effect? Minus I groups are examples, as well as I will cover examples and order of their minus I effect. I will give example as well as their minus I effect also. Which one has high minus I effect, which one has less I effect. Okay. So examples and also I cover order of their minus I effect. So which one has minus I effect? OR2 has minus I effect. Then NR3 has minus I effect. Then NH3 has minus I effect. Followed by NO2 group has minus I effect. Cyano group has minus I effect. COOH group has minus I effect. And what after COOH group, then minus I effect. Halogens have minus I effect. Then what? OH group has minus I effect. Then OR group has minus I effect. Then okay, 1 minute. In halogens, I want to write fluorine, chlorine separately. Fluoride has minus I effect. Then X means halogen. Fluorine, fluoride, chlorine. Then bromine has minus I effect. Then iodine. I want to write order also. After that OR has minus I effect. After that OH has minus I effect. Okay. Then CH triple bond has minus I effect. Then NH2 group has minus I effect. After that phenyl group has minus I effect. This is phenyl group. After that CH double bond CH2 double bond has minus I effect. Finally hydrogen. I am comparing with hydrogen. Hydrogen inductive effect is 0. That means when compared to hydrogen, all these have high inductive effect. So just I will write order. Highest minus I effect shown by OR2, then NR3, then NH3, then NO2 group, then cyano group, then carboxyl group, fluoro, chloro, bromo, iodo, alkoxy group, hydroxy group, then triple bond, NH2, phenyl group, double bond, hydrogen. For hydrogen, inductive effect is 0. Take this one. This is important. Right. After minus I effect, I want to write plus I effect. Positive inductive effect. Okay, what is positive inductive effect? Whenever displacement of sigma bond pair electron, electron takes place towards plus I effect takes place away from the substituent, away from the substituent, away from the substituent, away from the substituent towards the carbon chain, away from the substituent towards carbon chain, towards carbon chain. It is referred to as, it is referred to as which effect? Plus I effect. Away from the substituent towards the carbon chain. That means your carbon chain getting electron, plus I effect. Carbon chain is getting electron, so plus I effect. Okay. Examples for plus I group. Examples and order of their plus I effect. I will give some plus I groups. The group which causes plus I effect is plus I group, and also their plus I effect order also, strength of the plus I effect also. So first of all, which group? First of all, NH minus group, CH2 group has very high plus I, CH2 minus group, because they are carbon, less electron. Then after that NH group, NH minus also negative charge, it also push electron, this one also push electron. After that O minus also push electron. After that COO minus also push electron. After that tertiary alkyl group push electron. After that secondary alkyl group push electron. After that primary alkyl group. After that CT3 tritium, CT3 group. After that CD3 deuterium, carbon with deuterium. After that carbon with hydrogen, methyl group. Carbon with tritium, carbon with deuterium, carbon with isotopes of hydrogen. After that tritium, after that deuterium, after that hydrogen. What is inductive effect of hydrogen? Almost 0. Positive inductive effect 0, negative inductive effect 0. That means this is the relative strength with respect to hydrogen, relative strength. I am comparing one with other. So taking reference as hydrogen. When compared to hydrogen, deuterium has high plus I effect. Deuterium, so if you compare with deuterium, tritium has a high inductive effect, methyl, like this. Highest positive inductive effect caused by CH2 minus, not CH3, CH2 minus. This is the order, okay, which explain minus I effect. This is plus I effect. All these groups are plus I groups. When you see applications of inductive effect is important. Applications of inductive effect. There are many applications. Important application. Inductive effect explain stability of reaction intermediates like carbocation, carbanion, carbon free radical, like that. So stability of it explain, inductive effect explain, stability of stability of reaction intermediates. Reaction intermediates. Reaction intermediates. What are reaction intermediates? Carbocations, carbanion, carbon free radical, all these are what? Reaction intermediate. Of course, we have carbenes, benzenes, nitrines. Okay, it explains stability of carbocation. Otherwise, if you write separately, that become reaction intermediate. Stability of reaction intermediate, like stability of carbocation. Second application, inductive effect explain stability of carbanion. Third application, inductive effect explain stability of carbon free radical. Fourth one, it explain acidic strength of organic acids. Inductive effect explain acidic strength of organic acids like carboxylic acids, phenols, alcohols. And final point, inductive effect explain, I effect explains the basicity of amines also, basicity of amines in gaseous state, amines in gaseous phase. In aqueous state, that is different. Okay, so all these are applications of inductive effect. With the inductive effect, we can explain stability of carbocation, we can explain stability of carbanion, carbon free radical, we can explain strength of organic acids. So which one is strong acid, which one is weak base, we can compare relative acidic strength. Then we can also understand the basic strength of amines in gaseous phase. Okay, take this one.